We can all agree that we should be striving for a cleaner environment, but there's lots of different ideas on how to best get there. From this discussion, new green technologies and building techniques have emerged. Some have been overwhelming successes and will likely play an increasing role in the future, while others have been less successful, and still others have been downright disastrous. Today's video will look at 8 of the biggest green technology failures. Starting off at number 8, we have the Strata SE1 tower, nicknamed the Razor due to its distinctive shape, which many have compared to an electric razor. It was designed to be a groundbreaking, eco-friendly skyscraper in London's Elephant and Castle area. Completed in 2010, its most notable feature was 3 integrated wind turbines at the top, which were expected to generate up to 8% of the building's energy needs. However, the turbines proved to be a costly failure. Shortly after the building opened, residents complained about the excessive noise and vibration caused by the spinning blades. As a result, the turbines were quickly shut down and have remained non-operational ever since. The project's downfall stemmed from overlooking crucial engineering considerations, particularly the impact of turbulence and noise on the building's occupants. Critics have since labeled the turbines as greenwashing, an attempt to appear environmentally friendly without actually delivering any benefits. At number 7, we have the Perkolo Bridge in Norway. This timber bridge collapsed under the weight of, ironically, a timber truck, which highlighted concerns about the safety and design of wooden bridges across Norway. Using engineered wood products in place of steel has been touted as a way to move towards a more environmentally friendly and sustainable future. The lightweight glulam beams offer strength-to-weight ratios better than steel and are also surprisingly fire-resistant. But the failure of the Perkolo Bridge was attributed to an engineering mistake concerning the necessary strength at the timber joints. The incident prompted a thorough inspection of all wooden truss bridges in Norway. The Perkolo Bridge collapse served as a warning sign for potential vulnerabilities in timber bridge designs. It emphasized the importance of proper design, construction, and maintenance of wooden structures, especially those that would be subjected to heavy loads. The incident also led to recommendations for strengthening similar bridges, including the Tretten Bridge, which, ironically, takes us to number 6, the Tretten Bridge. It was a 486-foot timber and steel truss structure in Norway, and it collapsed in August of 2022 after only 10 years in service. The primary cause was a block shear failure in one of the timber diagonal members near the Western River Foundation. This failure led to the overloading of other truss elements and ultimately led to a catastrophic failure of the bridge. The use of glulam played a significant role in the bridge's design and failure. The combination of glulam and steel created unexpected tensions due to their different responses to temperature, humidity, and weight load variations. This unconventional design choice, coupled with inadequate caution in planning and inspection, contributed to the collapse of the bridge. The inspection revealed that the bridge's capacity against block shear failure was only half of what current regulations require. Insufficient knowledge sharing and insufficient follow-up on other similar incidents like the Perkolo Bridge were also listed as contributing factors in this collapse. Which takes us to number 5, the Wattway Solar Road. The solar road concept, once hailed as a revolutionary solution to energy production and road infrastructure, has largely proven to be an engineering and economic failure. The most notable example is France's Wattway project, a 0.6-mile stretch of solar panels installed on a road in Normandy in 2016. Despite an investment of over 5 million euros, the project has fallen well short of its energy production targets and suffered rapid deterioration. The issues that the road has faced have included low energy production due to the flat angle of the panels and shading from the vehicles traveling over it, rapid wear and tear from traffic, especially from heavy vehicles, damage from weather conditions, including thunderstorms, clogging from rotting leaves, reducing efficiency even further, breaking of the protective resin coatings, exposing the fragile solar panels. By 2019, the Wattway was producing only 25% of its projected energy output. Similar projects in other countries have faced comparable challenges, leading to many experts to conclude that solar roads are impractical and far less efficient than conventional solar installations. Moving on to number 4, we have the Crescent Dunes Solar Energy Project. It's located in western Nevada and was once hailed as a groundbreaking venture in renewable energy. But ultimately, it's become a costly failure. Launched in 2011 with a $737 million loan guarantee from the U.S. government, the $1 billion project aimed to generate 110 megawatts of power using concentrated solar thermal technology and molten salt as a storage medium. Concentrated solar power systems use mirrors or lenses to focus light onto a receiver, generating heat that drives a steam turbine, which then produces electricity. This technology allows for energy storage, enabling power generation during periods of low solar radiation or at night. Despite its innovative approach, the Crescent Dunes project faced numerous technical issues, including problems with its molten salt storage system and an unreliable power generation. The plant's high operating costs, with electricity priced at $135 per megawatt hour, made it uncompetitive compared to cheaper solar photovoltaic alternatives. In 2019, NV Energy, the project's sole customer, terminated its contract due to the plant's failure to meet production targets. The project's original developer, Solar Reserve, went bankrupt and the plant was shut down. However, in 2021, under new ownership by ACS, Crescent Dunes resumed operations and is now focusing on supplying solar energy at night using stored thermal energy. At number 3, we have the Garzweiler coal mine. At this coal mine, owned by German energy giant RWE, they've begun to dismantle some of the wind turbines that they installed in 2001 in order to expand the coal mine. This expansion will allow for the extraction of an additional 15 to 20 million tons of coal. The decision has sparked controversy as it appears to contradict Germany's commitment to renewable energy and climate protection. However, RWE argues that wind turbines were already nearing the end of their operational lifespan and were built on land that had previously been designated for coal mining. The company has agreed to phase out coal use by 2030, 8 years earlier than initially planned, as part of a deal with the government. Critics view this as a setback for Germany's energy transition, calling it absurd to dismantle clean energy sources for the expansion of a coal mine. Coming in at number 2, we have the Coca Codo Sinclair Dam in Ecuador, Ecuador's largest hydroelectric power project. It's faced significant issues ever since it was completed in 2016, which include structural issues with over 7,600 cracks identified in the generator hall and surrounding the critical equipment. This has raised terms about long-term stability. Possibly an even bigger problem has been the environmental issues that have emerged, such as regression erosion upstream and then high rates of erosion downstream as well. These have led to oil spills, the destruction of the riverbanks, and also the destruction of the San Rafael Falls. Despite these issues, the dam remains a critical source of power for Ecuador, with roughly 40% of Ecuador's daily electrical production coming from the hydroelectric dam. Finally, at number 1, we have the Grenfell Tower tragedy. It was a tower in London that caught fire June 14, 2017, and resulted, unfortunately, in the deaths of 72 people. The fire's rapid spread was significantly exacerbated by the building's exterior cladding, which had recently been added during a renovation aimed at improving energy efficiency and meeting environmental targets. The refurbishment of Grenfell Tower included the installation of this new cladding to improve insulation and reduce greenhouse gas emissions in line with stringent government targets set by the 2008 Climate Change Act. These measures were part of a broader effort to enhance the energy efficiency of buildings across the United Kingdom. However, the cladding that was used in the refurbishment was highly flammable. Reports indicate that fire-resistant alternatives were available but were not chosen, most likely due to cost considerations. Unfortunately, the flammable cladding that was selected is extremely common due to its combination of its high insulating properties and its low cost. The incident underscores the importance of seeing the big picture when it comes to green construction rather than getting singularly focused on one metric or standard. Making our environment cleaner and healthier is a worthy goal, one that we should all strive for. New technologies will come along and help make this a reality, but unfortunately, as is the case with all new technologies, there are going to be some hiccups along the way. Learning to incorporate these safely and practically will be vital to ultimately achieving the long-term goal of a cleaner world. So that's pretty much it. Thanks for watching. Let me know what you think. Could any of these incidents have been avoided, or are any of them critical learning moments that will help shape the future of green building? As always, if you like this video, please subscribe. New videos coming out every Friday afternoon.